This video will give examples on how to use partial fractions to integrate. Some of these will be somewhat complicated, but if we do all of them, we'll get a good understanding of all the different types of creating partial fractions that there are. So in this first case, we see that we have a fraction that violates the first rule of creating partial fractions, where we said that the degree of the denominator has to be greater than the degree of the numerator. So we're going to have to do some long division here. So I've got this, and now x squared goes into 3x cubed 3x times, and then we'll multiply out. So that's 3x cubed minus 3x squared minus 18x. Subtracting gives us x squared minus x minus 7. At this point, x squared goes into x squared one time, and so we have x squared minus x minus 6. Subtracting gives us negative 7 plus 6, or negative 1, for our remainder. This means we can now rewrite our integral as the integral of 3x plus 1 minus 1 over x squared minus x minus 6 dx. Now we know how to integrate this part, and with this part we can now create some partial fractions. So let's just take this out and we'll factor the denominator. That'll be an x minus 3 times x plus 2. Set that equal to a times a over x minus 3 plus b over x plus 2. So that's a times x plus 2 plus b times x minus 3 over our denominator, meaning that 1 equals a times x plus 2 plus b times x minus 3 for all x. Now I'm going to plug in negative 2 for x, and that'll give me 1 equals 0 times a plus b times negative 2 minus 3, or negative 5, meaning that b equals negative 1 over 5. And then I'm going to plug in 3 for x, and that'll give me 1 equals a times 3 plus 2, or times 5, and plus b times 0. So a equals 1 over 5, meaning that 1 over x squared minus x minus 6 is equal to 1 over 5 times x minus 3 minus 1 over 5 times x plus 2. Now we can take the integral that we had earlier and rewrite it again as the integral of 3x plus 1 minus 1 over 5 times x minus 3 plus 1 over 5 times x plus 2 dx. So the first part integrates easily as just 3 over 2 x squared plus x, and then the second part is minus 1/5 times the ln of x minus 3 plus 1/5 times the ln of x plus 2 plus c. And there's our final answer. Okay, so now if we look at this integral here, there's no way we can do it without using partial fractions. We see that the denominator has already been factored out for us. So we have a over 2x plus 1 plus b over x plus 2, And now remember that whenever you have a repeated term, you have to keep making new terms for it in your partial fraction expansion, so that we'll have a c over x plus 2 squared. So now we have that x squared equals a times x plus 2 squared plus b times 2x plus 1 times another x plus 2 plus c times 2x plus 1. And now if I plug in negative 2 for x, I'll end up with negative 2 squared a times 0 plus b times 0 plus c times negative 2 times 2 plus 1. So 4 equals negative 3c, and c equals negative 4/3. Now I can plug in negative 1/2 for x, and so that'll give me negative 1/2 squared equals a times negative 1/2 plus 2 squared plus b times 0 plus c times 0. So that means that 1/4 equals 9 over 4a, and so we have that a equals 1/9. And now in order to find b, since I have 3 unknowns here, a, b, and c, I'm going to have to plug in a third value for x. I'll just choose 0 because that one should be relatively simple. And that gives 0 squared equals 4a plus b times 1 times 2 plus c times 1. And so now we can plug in the values that we found for a and c. So 0 equals 4 times 1/9 plus 2b plus negative 4/3. And so solving this equation, we end up with b equals 4/9. So now we have our integral rewritten as the integral of 1/9 times 2x plus 1 plus 4/9 times x plus 2 minus 4/3 times x plus 2 squared dx. And at this point now we have it in a form that we can easily integrate. So we'll just write this, and it's now going to be 1/9 times 1/2 ln of 2x plus 1 plus 4/9 times the ln of x plus 2 minus 4/3 times negative x plus 2 to the power of negative 1, using the power rule there. And so simplifying real quick, that'll be 1/18 ln 2x plus 1 plus 4/9 ln x plus 2 plus 4/3x plus 2 plus c. Now we're going to do one final example of a case where one of the terms in the denominator is a quadratic. So we want to split our fraction up into 2 pieces, one of which is going to be something over x squared plus 3 plus something over x minus 4. But now instead of just writing an a like we usually would, we're going to have to write an ax plus b, because we have a quadratic in the denominator, and then this will just be c. So we have ax plus b times x minus 4 plus c times x squared plus 3 equals 5x squared minus 8x plus 9. Now if we plug in x equals 4, then that'll give us ax plus b times 0 plus c times 16 plus 3, or 19, equals 5 times 16 minus 8 times 4 plus 9, which is 57, so c equals 3. But now we can't just plug in something that'll give us a 0 to be multiplied by c like we usually can. So instead, we're going to have to distribute out these terms and see what happens. So when we multiply this out, we're going to get ax squared plus bx minus 4ax minus 4b plus cx squared plus 3c. And we'll combine the like terms here. So we get a plus c x squared plus b minus 4a times x minus 4b plus 3c equals 5x squared minus 8x plus 9. And what this implies is that a plus c must equal 5 in order for the coefficients to be equal, and b minus 4a must equal negative 8, and negative 4b plus 3c must equal 9. So from the first equation, if we plug in c equals 3 that we found earlier, we'll get that a equals 2. Then we can use our second equation and plug in the value of a that we just found. So b minus 4 times 2 equals negative 8 gives us b equals 0. And even though we found everything, we can just use this third equation as a check to make sure we got everything right. So negative 4 times 0 plus 3 times 3 is indeed 9. So we know things are probably going good. So now at this point we can rewrite our integral as 2x over x squared plus 3 plus 3 over x minus 4 dx. Now for the first part, we're lucky we can just do a simple u substitution, and so that'll give us for our answer the ln of x squared plus 3 times the ln of x minus 4 plus c.